Hi, in this presentation, I'm going to show you how the Tritanium business blockchain solves one of the most important challenges businesses face as part of the core functionality of the blockchain. So let's start with a little background. The architecture of the original Bitcoin blockchain was designed to be a peer-to-peer cash transfer system. The transaction mechanism used, called UTXO, requires the inputs to each transaction to be outputs of other transactions. Each coin in the blockchain is represented by a chain of transactions and digital signatures. This allows the history of a coin to be traced from its current owner all the way back to when the coin was mined. Although traceability is only a byproduct of the Satoshi blockchain, it solves an enormous challenge for businesses. The traceability of assets is vital in food production, manufacturing, pharmaceuticals, and many other industries, allowing the blockchain to become a groundbreaking tool. So let's see it in action. I'm going to start by navigating to the tritanium.info website to demonstrate the capabilities of the business blockchain. The website is a generic interface to the blockchain originally designed for developers to test features of the blockchain. So if you want to walk through the process yourself, you can go to the website and follow along. The web interface performs no validation since the blockchain needs to be able to handle whatever application developers send it. The navigation buttons on the left take you to the basic functions of the interface. Most of these functions are not things you would see in a business application. From here, developers can look at blocks in the blockchain and force blocks to be mined. They can view the key value store and test rebuilding it. They can also view things that are not relevant to this presentation, like systems, channels, and nodes. The first thing we need to do is create an identity to use the system. Just like any other blockchain, an identity is an address, identified by a public key containing a private key used to validate and sign transactions. I'm going to click on the New Identity button to display the page used to create and load identities. Again, this page is only for demo and testing purposes, so you would never manage your keys like this in a real application. I'm going to click the Create Identity button to generate an address, a public key, and a private key. Now that our wallet has an address and the key it needs, I'm going to click the Home button to return to the home page. Now at this point we don't have any assets, so I'm going to create our first asset by clicking the New Asset button. Within the blockchain, everything is an asset, and the blockchain doesn't care what the asset is. The original blockchain only supported a single type of asset, the coin. Although businesses need to support an unlimited number of assets, within the blockchain, everything is treated the same. The Tritanium business blockchain provides complete flexibility. On this page, we have two fields that are required, the asset type and the asset code. These fields, along with our blockchain address, are used to create a 32-byte identifier for the asset. In our demo, I'm going to start as a farmer growing wheat. A truck just arrived with a shipment of seeds, so I'm going to enter the asset type of seeds and the asset code of lot 1, 2, 3. The blockchain does not require that applications predefine asset types or define the format of the asset codes. Front-end interfaces and business rules are the responsibility of the application developer. In this case, the interface of the blockchain is a barcode scanner or RFID reader. Next, we want to enter some attributes of the asset. To do this, I will click the Add Attribute button. Now I can enter an attribute name and a value. I will enter quantity as the attribute name and 100 as the attribute value. Moving on, next I will add a second attribute called unit of measure with a value of kilograms. And to finish creating the asset, I will click the Create Asset button. The asset just created is now in our list of assets, and I can click on it to display it. The asset dashboard shows my seeds, the asset code, the asset identifier that was created, and the attributes we added to the batch of seeds. We can upload a document like a scan of the invoice or shipping document to be stored on the blockchain, and we can add additional attributes to the asset at any time. The other thing we can do here is add inputs or outputs to the asset. Since we are growing the seeds into wheat, I'm going to create wheat as an output of the seeds. First, I'll click on the Create Output button. Then I'll enter the asset type of wheat and give it an identifier. I will just call it Plot 1 to identify where the seeds were planted. So at this point, we are changing an asset from one thing to another, and we are not transferring anything to another party. So the address field is left blank. Next, I'll select the Create Output button to create our wheat from our seeds. Now, if we look at the output section of the screen now, we have wheat as the output of the seeds. If I click on the wheat to display it, we see the seeds are an input to the wheat. This is how the blockchain provides traceability. Assets can be formed from inputs and transferred as outputs to other assets. And just like the Satoshi blockchain, assets can be split into multiple assets or combined into new assets. Okay, so next I'm going to add a couple of other inputs related to the wheat, the fertilizer, and the pesticide. In this simple example, there are very few inputs. But if you look at the ingredients on any food packaging, you will see why using the blockchain to solve traceability is an incredible opportunity. The two buttons at the bottom of the screen call two functions built into the blockchain to trace history. When I click Track History and then Run Trace, the system generates a JSON array tracing the entire product history. Next, let's prepare the wheat to be shipped to the mill by creating an asset representing the shipment. So I'll select the Create Output link, enter shipment as the asset type, and a shipment ID that represents the shipment. Once a shipment is prepared, we can transfer it to the mill by creating a new output with the blockchain address of the mill as the transfer address. I'm going to enter the same asset type and asset code, but this time include the blockchain address of the mill. What this does is create an asset for the mill to receive. To show this, let me click the Home button and then the Create Identity button, and I'll paste in the blockchain address of the mill and select Load Identity. Now that we've logged in as the mill, we can receive the shipment by entering the same asset we just created. Now that the asset is received, the receiver at the mill can see what the shipment is supposed to contain. As you can see, this not only allows the blockchain to provide complete traceability, but also allows the blockchain to be used to build time-saving functions. When the mill turns the wheat into flour and then sends it to the baker, who turns it into bread, who then sends it to the sandwich maker, who makes packaged sandwiches, the blockchain can be used to trace the source of every ingredient in the sandwich. And there you have it. This demo shows the core functionality of the business blockchain as a foundation to an important set of use cases. It also shows that the original principles of the original Bitcoin blockchain continue to be revolutionary. The Tritanium business blockchain is designed to make these principles fast, flexible, and easy to deploy.